my physics project, I am going to be analyzing a scene from the game Kirby's Forgotten Land that was released in March of 2022. In the game, the player must guide Kirby through various stages in order to save all the Waddle Dees while learning new abilities and making friends along the way. A group of 3 Woofies appear from behind the car and charge at Kirby. Kirby inhales them all, as well as the car, stretching his mouth over it with his newfound ability, Mouthful Mode. What I'm going to analyze in the game is the amount of force that is needed for the Kirby car to smash through the warehouse while being in turbo mode and whether or not it is realistic in real life. The physics applications being used are dimensional analysis, collisions, and momentum specifically. We will be finding the potential force needed to overcome the wall and then the actual momentum that can be calculated from the situation. Punching force is the potential force needed to break the wall. To calculate the punching force, we are going to use the equation. We would need to multiply the perimeter of the car, and in this case we are going to use a rectangle, the plate thickness of the wall, and the shear strength of what the wall is made of, which is aluminum. For finding the dimensions of the thickness of the wall, we need to discuss how warehouse plating works. We're going to assume the plates are aluminum and are 3/16 thick, which are about 0.188 inches. There are usually 2 metal plates that are a foot apart with insulation in between the wall plating. Since there are 2 layers of aluminum sheets, we are going to add the 2 together to get our thickness of the wall and convert our value to millimeters. To find the perimeter of the car, we are going to use the classic Mini Cooper print model's dimensions. Using the equation length times width, then multiplying the value by 2 to get our perimeter. Our length is 1.35 meters and our width is 1.24 meters, which gives us 3.348 meters for a perimeter, but we have to convert this value to millimeters. For our equation, we are going to use the value 0.1724 for our shear strength of aluminum. So we get 3,348 millimeters times 9.525 millimeters times 0.1724 to get 5,497.78 kilonewton. To find momentum, we are going to use the equation P equals mv twice since we are going to find the momentum before the wall crash and after the wall crash. First, we would need to estimate the distance that Kirby initially traveled by using the wooden pallets as a reference. We were able to measure about 4 pallets to the wall. By finding the average size of the wooden pallets, we can estimate the distance from this point, which results in the wall being 4.87 meters away. We got this number by getting the average pallet size, which is usually 48 by 48 inches, and estimating the distance by measuring it in pallets. By converting it to meters, we now have a total distance from that point to the wall, which is 4.87 meters. To get our velocity, we just need to calculate the seconds it took from the wooden pallets to the wall, and by that we could just count the frames per second from that point till the impact and divide it by 30 FPS. A total of 36 frames were counted, and dividing by 30 we get 1.2 seconds. This gives us the information to find the velocity, so now we divide by 4.87 meters over 1.2 seconds, and our result is 4.058 meters per second. Next, we need to find the second velocity after the Kirby car smashes into the wall and flies off. To measure the distance, I looked through the frames to where Kirby's distance after the wall crash was about half the car size, which is 1.52 meters. Counting the frames up until the point was at 13 frames, we divide by 30 to get 0.433 seconds. An average of classic Mini Cooper's model would be 282.5 kilograms, while Kirby's mass is 3.8 kilograms, which gives us a total of the Kirby car being 286.3 kilograms. We then can use the velocities calculated to give the momentum by using the equation P equals mv. Our momentum after crashing into the wall minus the momentum before the crash divided by the time after the crash will give us negative 362.33 newtons. Based on the calculations of the actual force being significantly smaller than the potential force needed, the Kirby car's animation is not realistic and would need a much greater amount of force to break through the aluminum plated wall.